everyone, Simi here. I'm excited to announce an upcoming multi-agent-based development course for senior Gen AI folks, led by the brilliant Abhinash Mishra.
Have you ever opened an app on your phone and noticed something's different? A new button, maybe a bug that was annoying you is just gone? It's like magic, right? Well, today we're going to pull back the curtain on the invisible factory that makes all of that happen.
I mean, really think about that for a second. How does a brand new idea, a complex piece of code, get from a developer's brain onto their keyboard and then safely into the banking app on your phone, sometimes in just a few hours? The answer is this amazing automated process that works just like a high-tech factory.
You know, it wasn't always this easy. Not that long ago, releasing new software was a total nail-biter. It was slow, everything was done by hand with these massive checklists, and it was super risky. One tiny mistake could take the whole system down. But the new way, it's the exact opposite. It's fast, it's automated, and it's designed from the ground up to be reliable. And this new way of doing things is all powered by a philosophy called DevOps. It's all about bringing the development teams and the operations teams together. The whole point is to build, test, and release software really fast, but also safely. It's kind of like a modern car factory, all about efficiency, quality control, and speed.
Okay, so to really get this, let's follow one single piece of code. Let's say a developer just fixed an annoying bug. We're going to watch that one little fix travel all the way from their computer to a live app that you can use.
So, the whole journey starts with one simple action. It's called a commit. All that means is the developer is saving their changes to a shared central library of code. Think of it like saving a file to a shared folder. But that one little click, well, that's the spark that turns on the entire factory.
The second that code is committed, it enters the first big test. We'll call it the integration gauntlet. This is the world of continuous integration, or CI for short, and its job is to immediately see if this new code is good enough.
So what is continuous integration? Well, it's an automated process that basically asks one critical question every single time a developer saves their work. Hey, did this new change just break anything? By automatically building the software and running a bunch of tests, it finds bugs right away, not weeks later when they're a huge pain to fix.
And that commit kicks off this instant chain reaction. First, the system automatically builds the code, turning it into something that can actually run. Right after that, a series of unit tests make sure all the individual little pieces are working right. And finally, it gets scanned for quality.
And that last step is so important. You have these tools, like SonarQube, that act as a guardian of code quality. It's like a robot inspector that checks every single line for potential bugs or security issues. And if the code isn't good enough, the factory literally stops. The change gets rejected right there, before a bad part can ever make it down the assembly line.
And this brings up a really key point. The specific tools might be different. You might use something called JUnit if you're writing in Java, or PyTest for Python, but the core idea of automated testing is totally universal. It's a non-negotiable part of any modern software factory.
All right, so our little piece of code survived the gauntlet. Awesome. Now it moves on down the line to the next stage, the delivery assembly line. This is where we get into continuous delivery and continuous deployment, or what everyone just calls CD.
The first flavor is continuous delivery. The key idea here is that the software is always ready to be released. At any moment, it's fully tested and packaged up. But the final step of actually pushing it out to the world still requires a human to press the big green Go button.
Then you have continuous deployment. This takes it to the next level. This is the full automation dream. If a change passes every single automated test, it's automatically released to customers. No human intervention at all. It's a huge sign of confidence in your automated factory.
So let's make that super clear because it can be a little confusing. Continuous delivery means the rocket is on the launch pad, fully fueled, ready to go. You decide when to hit the launch button. Continuous deployment means the moment that rocket is ready, the countdown starts automatically. Launch is automatic.
So the path to get there looks something like this. First, the app gets packaged up into something called a container, which is just a neat little box with everything it needs to run. Then, a new round of tests, acceptance tests, make sure the whole thing works together. If it passes, it gets a version number and gets published to a central library, kind of like putting the finished product in the warehouse, ready to ship.
Okay, I know, that was a lot of technical stuff. So let's zoom out. Why go through all this trouble? Why build this whole invisible factory in the first place? Let's talk about the real-world impact.
It really boils down to speed. Remember that first set of checks, the integration gauntlet? The goal is for that entire process to take less than 2 minutes. Think about that. A developer gets feedback on their work almost instantly. They don't find out about a mistake days later. They know in moments, when the code is still fresh in their mind. That is a massive game changer for how fast you can build things.
So when you put it all together, this whole factory really gives you 3 huge benefits. First is security, because those automated scans are always looking for problems. Second is speed, because you can go from an idea to a live feature in record time. And third, and maybe most important, is stability. All that relentless testing means way fewer bugs ever reach you.
And that right there, that's the bottom line. For all of us. This whole invisible factory, this is why your apps get better all the time. It's how that bug fix shows up the next day, how that new feature appears out of nowhere, and how you get security updates faster and more reliably than ever before. So the next time your app updates itself, just remember what's happening behind the scenes. There's this incredible, invisible factory humming along 24/7, building and rebuilding our digital world, one tiny, perfect piece at a time.
Folks, I hope you are liking our content and it is adding up nicely in your skill set database. If so, hit the like and subscribe button.
All right, let's talk about something that is a total game changer for any developer: automation. We're going to dive into how you can stop doing the tedious, repetitive parts of your job and let the machines handle it. We're going to pull back the curtain on GitHub Actions and see how this amazing engine really works. I mean, we've all been there, right? You make a tiny change, hit save, and then this long checklist of chores pops into your head. You got to run the tests, then you have to build the package, then you have to push it somewhere. It's not just boring. Every single one of those manual steps is a tiny little doorway for a mistake to sneak in. Well, there is a much, much better way. And the best part? It's built right into the place where your code already lives, GitHub. It's called GitHub Actions, and it's designed to take all of that repetitive work off your plate so you can get back to doing the fun stuff, actually writing code.
Okay, so to really get how this all works, I want you to picture a factory assembly line, but for your code. It's a great way to think about it. We're going to break down all the key parts of this production line piece by piece.
Every good assembly line has to start with a blueprint, right? A master plan. In GitHub Actions, that's called the workflow. This is the whole instruction manual for your automation, and it's all defined in a simple text file, a YAML file that lives right there in your project. But a blueprint just sits there until something kicks it into gear. That trigger, in the world of GitHub Actions, is called an event. This could be you pushing new code, or maybe a teammate opening a pull request. It's basically the start button on the assembly line that gets everything moving.
So where does all this work actually happen? Well, that would be on the factory floor itself, which we call a runner. This is just a server. It can be one hosted by GitHub or even one you set up yourself that grabs your workflow and starts executing all the instructions.
Now, a workflow is usually made up of one or more jobs. A job is like a specific workstation on our assembly line. So you might have a testing station job, and then right after that, a separate packaging station job. Each one is a distinct phase of the process.
And if we zoom in on one of those workstations, we see the individual tasks being performed. These are called steps. A step is the smallest piece of the puzzle. It can be a simple command you type in your terminal, or it could be something more complex.
And this is what makes the whole system so incredibly powerful. Many steps use something called an action. Think of an action as a pre-built specialized tool. Maybe it's a tool for setting up a specific programming language or one for logging into a cloud provider. The community has built thousands of these, so you almost never have to reinvent the wheel.
All right, so we've met the whole crew, right? We've got our workflow, the event, the runner, the job, the steps, and the actions. Now let's see how they all snap together and actually get some work done.
I mean, it's one thing to know all the jargon, but what does it actually feel like? How does the assembly line fire up the moment you commit your code? Let's walk through it.
Okay, here's the play-by-play. You push your code. Boom, that's the event. GitHub sees it instantly and triggers your workflow. A fresh runner spins up to handle the job. Then it just marches through your steps one by one. First build the code, then run the tests, and maybe deploy it. And at the end, it reports back with that beautiful green check for success, or, a red X if something went wrong. It's clean, it's simple, and it's all automated.
Now, just the basics alone are seriously powerful, but GitHub Actions has a few tricks up its sleeve that can really supercharge your whole development process. Let's look at a couple of my favorites.
So, have you ever had that little worry in the back of your mind? You know, the code works great on your machine, but what happens when it runs on a Windows server or on Linux? Or what about different versions of Python or Node.js? Testing all those combinations by hand is, well, it's a nightmare.
And this is where the matrix build strategy just blows the old way out of the water. Look at the difference. Instead of this slow, painful one after the other process, you just tell it all the combinations you care about, and it tests them all in parallel, all at the same time. You find out instantly if your code works everywhere. It's a massive time saver. Speed is fantastic, but the second your automation needs to do something like, say, talk to a database or deploy to a cloud provider, you run into a really important question. What do you do with your secrets? You know, your passwords, your API keys?
So here is the #1 golden rule. You never check secrets into your code. Ever. Instead, GitHub gives you a secure little vault built right in. You can store your secrets at different levels, for just one repository or for your whole organization, and GitHub will safely inject them into your workflow only when they're needed. And this is the really clever part. GitHub Actions is smart. It knows this information is sensitive. So even though your scripts can use the secrets, it automatically scrubs them from any logs. So if your workflow fails and prints out a ton of debugging info, you never have to worry about accidentally leaking your credentials to the world. It's a huge security win.
Whew! Okay, we have covered a lot of ground here, from the tiny building blocks all the way up to some really advanced features. So let's just zoom out for a second and boil this all down to what this automation toolkit really means for you.
When you put it all together, you really see 3 massive benefits emerge. You get a huge boost in speed from automation and parallel testing. Your code quality goes way up because you're running tests consistently every single time. And you're doing it all with better security thanks to features like the built-in Secrets Vault.
So why does this matter to you? Well, you get to automate away the boring stuff and just focus on being creative. You're going to catch bugs way earlier in the process, and you can deploy your code with so much more confidence. And honestly, just go explore the GitHub Marketplace. You will be amazed at what the community has already built, ready for you to just plug into your own workflows.
So, we've laid out the entire assembly line for you. You have the blueprint now for building your own powerful, secure, and super efficient automation. So the only real question left is, what's the first tedious task you're going to get rid of forever?
Folks, I hope you are liking our content and it is adding up nicely in your skill set database. If so, hit the like and subscribe button.